exactly 2 o'clock. So again, everybody welcome to today's webinar, How to Take Up Materials Related Challenges in Undergraduate Teaching, hosted by Infinite Simulation Systems colleague Sarah van der Wand and co-organizer Wen Sao from NSYS Granta Education Team as an academic development manager for Europe and Asian. This webinar has a duration of 1 hour. And before we get started, I just want to show you this screen. We would like to go over a few items so you know how to participate in today's webinar. We have taken a screenshot of an example of your interface, and you should see something like this on your screen in the upper right corner. By clicking on the red arrow, you can unfold this a little screen and show your audio mode and questions. You are listening and using your computer speaker systems by default. And if you would prefer to join over the phone, you just select the telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions or chats during this event. And at the end of each topic, we will collect your specific questions. During the webinar, you are automatically muted, and this webinar will be recorded, of course. So the speakers for today are, what I told you, my colleague Sarah van der Wand. She is responsible for inside sales at Infinite Simulation Systems, and Wen Sao, Academic Development Manager of NSYS Granta. And the agenda for today is, of course, the introduction of Infinite and NSYS Granta by Sarah, and then NSYS Granta Academic Products of Material Research and Education by Wen. And then finally, at the end, we have the questions and answers. And now we'll give the stage to you, Sarah. Good luck, everybody, and enjoy.
Thank you very much, Erna. And let me check. There we go. First of all, of course, welcome everybody. I would like to introduce with the Infinite company situation. So since the beginning of 2020, we have joined both GPO Solutions and Cat Corner within the 4ITGO group. Cat Corner is a PTC business company based in Belgium, in Kortrijk. And GPO Solution is also a PTC business company based also in Breda, which we also are based in. So what do we exactly do? Although GPO and Cat Corner are in the PTC business, which is CAD, CAM, also PLM and IoT, it is very helpful that we can exchange our knowledge. With both their business and our NSYS business, we can combine it to provide a lot of customers to enhance their complete product cycle management or process or anything else that they need help with their digitalization. What do we then exactly do? So within the whole region of the Benelux, so Belgium, Netherlands, and Luxembourg, we serve over 750 customers. And at this moment, we have a little over 50 team members. We provide all these customers with services. So we provide, of course, help with setting up the licenses, with providing them with the right advice. And then again, of course, the software and the instructions how to install it. And further, we also have a lot of training possibilities. Not only does NSYS have them as well, we have a big support department where we provide trainings, but also just general support in helping you understand certain results of your NSYS simulations. But today we are going to talk about a new acquisition or fairly new acquisition of NSYS, which is Granta. Probably and hopefully will sound familiar because Granta actually already exists since 1994. It was designed or developed at the University of Cambridge by 2 professors specialized in materials. It was very helpful for them, it was very helpful for the students, and it was quite renowned at that time to have such a large database available with all this material data. Over the years, this database, of course, has grown, and then with a strategic partnership in 2004, Granta has made its name significantly in the materials world. Since 2004, we already have CES EduPack, so that's probably, I hope, where you know it from. CES EduPack is one of the largest material databases specifically designed for professors, for graduate students, for everyone working in materials and has to do material selection. Then maybe one of the bigger things that involves ANSYS and ANSYS's channel partners. In 2019, ANSYS acquired Granta, which then also changed the name of CES EduPack to ANSYS Granta EduPack. Then a little bit more detail about Granta, which my colleague Gwen will definitely tell you a little bit more about. But in general, Granta is a very large material database. With this material database, you have all the properties available to put the material properties to your model, so you can prepare it for simulation, but also just for material selection. Further, they have developed multiple tools where you can also do material information management, which is also very helpful today because it's actually something that isn't very, doesn't really exist. So let's go further to the different tools that Granta provides, which is, of course, Granta EduPack, mostly based for our engineering, universities, schools, any education where materials are in place. But next to that, there are also 2 other major Granta products, which is Granta Selector, which is the commercial variant of Granta EduPack, and Granta MI. Granta Selector, as well as Granta EduPack, is mostly used for material selection and material acknowledgement, whereas ANSYS Granta MI is mostly used for information management. It gives you the ability to build your own database, as well as use the materials that are in the database of Granta, and then add your own materials to it. Let me go further. So here you can see that not only here in the Benelux, but actually all over the world, there are multiple customers that use ANSYS Granta products every day. You can see there are a lot of universities that you may know that already use Granta EduPack. If you want, we can give you a lot of advice on how these specific universities or schools provide their students with the help of Granta EduPack. So that was a little bit the information in short. I will now give the word to my colleague Gwen, and she will tell you more about EduPack in detail.
Thank you, Sarah. So I will try to share my screen with you now.
Shall I? Yes, it's working then.
So I will just try to share the thing. Please let me know if you're seeing the correct screen.
Yes, correct, Ben. Thank you very much.
Okay. Thank you, Erna. Thank you. So thank you very much, everybody. Hello. And I think before we get started with our journey through ANSYS Granta EduPack, I would like to introduce myself a little bit about my roles. As Erna and Sarah mentioned, my name is Wen Zhao, and I'm part of the ANSYS Grant Education team, and I am supporting and coordinating materials-related educational and research projects in universities and research institutes with ANSYS Grant EduPack and Selector. So on the screen now, this will be our agenda for the coming session. Briefly speaking, we will go through overviews of ANSYS Grant EduPack in supporting materials related teaching. I hope towards the end of the session, it will be helpful for you to see the potentials of ANSYS Grant EduPack in supporting materials related education. So as Sarah mentioned, in 2019, the former granted design was acquired by the ANSYS simulation, by the engineering simulation leader ANSYS. During the 2020 release, we have rebranded the software as Grant EduPack. During the same period of time in Benelux region, we are getting more local supports from Infinite Simulation Systems on Grant EduPack. With more than 25 years experiences in the fields of computer-aided engineering with a focus on the finite element methods, Infinite is ready to help with the most challenging design questions with different products through their high-quality training and support together with our education team. So if you're interested in undergraduate materials-related teaching, Grant EduPack would potentially be a helpful and handy tool here. So let's go and explore a little bit. ANSYS Grant envisions material intelligence integrated throughout education, R&D, and product lifecycle. Through Grant EduPack, we help educators build society's material intelligence and to inspire the next generation of engineers, scientists, and designers in the subject vital to technological advances and sustainability. Currently, we have presence in different continents. With major presence, we can see from the map shown on the screen that we have a major presence in North America and in Europe. And currently, we are also experiencing fastest growth in Asia. So in summary, there are over 50 countries around the globe and over 1,300 educational institutes using Grant EduPack supporting their materials education. So Grant EduPack can be applied to a broad spectrum of engineering subjects as well as in interdisciplinary areas that are linked to materials education. It comes with the educational software, as well as with more than 350 teaching resources covering various levels of materials education, to which we will learn about how to access later. And I would like to start with some new features of our latest development to show how Grant EduPack is developed based on the needs and feedback from academics all the time. In 2020, besides including a new name, a new packaging, and a new license form, we also introduced two new databases, the medical and the design databases for introductory level teaching. In addition, to support advanced courses, we also included some of the advanced tools from Grant Selector into Grant EduPack and enhanced the links to simulation software. In addition, during our latest 2021 release, now EduPack is fully integrated with ANSYS Workbench. If you're using any of the ANSYS simulation software, it might provide a handy way. And also, if you would like to use material information for your simulation, this is a function that you might be interested. And data-wise, we have new battery cells data and battery designer tool. In addition, we have two medical devices on masks, just trying to keep up with what is happening around us and also share some new medical devices that is related with the students' life that make it slightly easier for them to understand. And here are all the different databases that make up our Grant EduPack. We also have many tools in the middle on the screen here, helping with learning about materials, which are also tools that are widely adopted in companies and industries with material selection projects. And these databases and tools are divided into different teaching and learning levels of introductory and advanced. Therefore, we have two editions of Grant EduPack correspondingly. Here are all included in the introductory edition. We can see that in the introductory edition, we have up to level 3 databases with over 4,000 engineering materials and 246 processes together with these basic tools. First of all, on material selections, and then we also have the equal audit tool to you if you are in need to do a very brief life cycle inventory analysis. And comparing with the introductory edition, the full edition will have these extra databases and tools. There will be more data to a specific subject. For example, we have aerospace, we have bioengineering, we have sustainability, and more listed here. And within this database, we have extra data such as temperature-dependent data or legislations and regulations relating to sustainability in different countries. So therefore, the advanced, which is also the full version of EduPack, is intended for example, capstone design projects and real-world problem sets. Well, some other highlights that might be interesting would be, first of all, the phase diagram tool. We have developed this interactive phase diagram tool on lever rule, phases, cooling paths, and phase diagram data tables to help teach concept on the slightly difficult phase transitions. In addition to that, we also have a new database from last year, the design database. And the feature of database is that it is utilizing products as gateway to innovation and design with materials and processes. Well, for the medical devices, I have briefly mentioned about this when I talk about the extra data we have for 2021. For this medical devices database, it inspires medical engineering students by connecting material data to information on 50 examples of medical devices. And with the extra 2 medical devices on masks, so we have 52 in total in medical devices database. And for all the advanced databases and tools, I will show you our most comprehensive sustainability database as an example. So this database contains more than 4,000 engineering materials and more than 240 processes as the rest of the advanced databases. In addition to that, this database has increased information on, first of all, durability, eco-property, and country of origin, together with information, for example, on the nations of the world, as I mentioned slightly before, the regulations and legislations in different countries. Therefore, it basically provides a comprehensive database for advanced teaching and projects in sustainable development, as well as facilitating material selection as the rest of the tools and database we have. It also provides supporting data for an analysis of different stakeholder perspectives on technological issues. So in a word, the sustainability database is aimed at higher year university teaching, project work, and real design projects. So with this database, our aim is to help students understand the complexities of sustainable development and gain skills in information analysis and debate, and prepare students to be ready to take a full part in policy decisions, as well as technical decisions in the context of sustainable development. So I guess until this point, maybe the best thing now is that if I take you on a tour around Grant EduPack within the software itself. So let me bring EduPack into view now. So Erna, could you please confirm?
Yes, please. It's I confirm. Okay. It's okay, Ren.
Thank you.
You're welcome.
Thank you very much. So, so since you've already have the software insights, maybe I can show you a little bit on this end. So here we are currently in the Grant EduPack now. Before I show you some of the functions, I would like to show you the material universe database so that you can get a feel for the depth and breadth for the data that EduPack contains. And after that, I am planning to use the charting tool to create one signature material property bubble chart and another chart with geographic data from the nations of the world to emphasize on the data depth. So here on the opening screen, there are all the databases I have mentioned that are covered in Grant EduPack. So if we slowly scrolling to the right, we have our level 3 sustainability database here, which I'm going to use that for the demonstration today. So when we click through, we will see that we can first of all select a data table to work with from the left-hand side, and then even go down to a material subset if we want to, if we don't want to work with all the materials. Well, on the right-hand side, we have links to, first of all, video tutorials to give a bit more detail on how to use certain kind of tools or databases with 3 to 5 minutes long video clips, and also a little bit on the database information, also the direct link to the Education Hub, which I will cover later in the session, and also some other resources that you might find useful for your courses. And since, as I mentioned, the sustainability database is the most comprehensive database in Grant EduPack, there are all different data tables that are available here. So we have, first of all, materials universe and process universe as most of the other databases. In addition to that, we also have information, for example, on nations of the world, and going down slightly, we have the legislations and regulation information, as well as, if we go down to the bottom, the brand new table of generic battery cell data. So on the tools end, there are 3 basic tools on the main toolbar. We have browse, search, chart, and select. So maybe let's start with the browse. So when we click on the browse, we will see the material family tree. So this is a very quick way of seeing what data is within the system. Here you can see that we are covering all different kinds of engineering materials. Maybe we shall look to open one of them as an example so that we could see what kind of information is covered here. So maybe let's just use polymer as an example. And when we click through, first of all, we will see that we have elastomer and plastic folders. So if we further click through to plastics, we will find that we include all the main thermoplastics and thermosets which are available on the market. So if we further click through to thermoplastics, on the top of the list, we will see ABS. And going further down, we will see that for the ABS material, we're not having just one grade of material, but instead we have unfilled, glass-filled, carbon-filled ABS. And under each folder here, for example, for the glass-filled ABS, we are not just having one record. We have different types of that as well. We have different types of molding. We have different type of fibers, short fibers, long fibers. And even for the unfilled ABS, we are not, we are having more than one records here with different flavors. So I'm going to open up a data sheet, for example, of this extrusion grade of ABS. We can double click to open it. And this would be a very typical data sheets that you will see for all polymers in the database, and actually for most of the materials as well. So it usually starts with a trade name, some typical uses of this material, and then we will see a session that covers the composition overview. Follow that, if we're scrolling down a little bit, follow that we have some price information, which is slightly harder to access, and we will also update this annually. And for this price, we can see that we are having price both in currency per kilogram and currency per unit volume. And if we go in further down, we'll have the technical properties. First of all, we have some mechanical properties, including here Young's modulus. We have some strength information, some property covering hardness and more. And you might notice that for all the data here, we are quoted a range for each of these. And that's because for this exact extrusion grade of ABS material, we can expect the Young's modulus to be between 2 and 2.9, depending on the specific grades on different suppliers. So if we're going down further, we can also see we have actual properties on impact, on thermal, on electrical, on magnetic, optical, and many more. Well, if we scrolling further down, we will reach the session that's on durability and more on the eco end. So we can see that here we summarize some of the environmental properties. We can see from these that we can see if we can use this data to see if this material is restricted and what is, for example, if we scroll down a further bit, for example, the water usage for the primary production of this material, and about carbon footprint, embodied energy, and also some end-of-life information for this material, which are quite useful when we want to consider the environmental impacts of the material. And as I mentioned, that we have links to other data in our data tables. So that is why at the bottom of each data sheets, we have the section called links. And use these links here, you can click through to other data sets within the different data tables freely. For example, if I click through to the process universe, it will directly return with a list of processes that can be applied on this extrusion ABS material. And so what will a typical process datasheet look like? Maybe we can like randomly open one of them. So I've got the selective laser sintering for polymers here, and this is how the process record is generally arranged. So we have descriptions at the top of the records, followed by some process schematic for students to understand the process in a more visual way. And if we're scrolling down, we have some other parameters for the process that is very important if we're choosing this to produce the material we need. In addition to that, from the supporting information section, we also provide some design guidelines, technical notes, and typical uses, just to make sure that when students are choosing to use this process, they understand some of the basic guidelines and they don't make mistake from here. So that's all about browse and how the datasheet is usually arranged. And the next tool we have on the main toolbar is the search tool, which is quite simple and direct, working as all the searching engines. So you basically put in the word you need. Let's stick with ABS here. And then hit on return, we will have the list of all the the records that contains the word ABS in the data sheets returned. So we can see this is our current material of interest, the extrusion grade of ABS. So it's quite simple and direct. Maybe we can move on to create some charts here instead. So in order to create the property charts, we can use the third tool on the main toolbar, the chart or select tool. And this will bring up the selection project panel. First of all, it shows that we're currently working at level 3 sustainability database, and we want to use all the materials in the material universe for the chart we're going to create. And of course, if you click on it to open the drop-down menu, you can also choose the material of your interest, maybe just focus on metals or the foams. But for now, let's still use all the materials in the materials universe. And from the results panel, we can see that currently in the materials universe, there are almost 4,200 grades of engineering materials. And all of these materials, I will use them to create the two charts I have mentioned. So the very first one is the our signature property charts. We'll use this chart or index tool to create that chart. And for example, for the chart itself, when we click through to the charting tool, we will have this window asking us to put properties on each axis. So for example, if we want to find a material that is stiff and light, then we want to check the Young's modulus and density. So what we can do now is to find them from the drop-down menu here. Young's modulus is a mechanical property, and then for the density is a physical property. We can easily find them under the drop-down menu, and that's how we put both different accesses and click on OK. As simple as that, it will bring us immediately the bubble charts with Young's modulus against density. So this is a very easy way for us to visualize the properties and understand the distributions of different material families on this chart to help us identify the good candidate for our application. So as I mentioned, we can use this show family envelopes to circle different material families, and by click and drag, we can label the different material families as easy as that, so that we can discuss later why they are distributed, why they are occupying different areas on this chart. And as I mentioned, we want to find material that is stiff and light. So from this chart, we can see that the materials on the lower left-hand corner here might be good candidates. And then from here, we can continue to add other restraints to get a final candidate for whatever the application. So that is one of the charts I would like to show you. And then in addition to this, I would also want to show you another kind of chart that is kind of special that can be created within the sustainability database only. So this time, as I mentioned, for these property charts, I use all materials in the materials universe. But to create this special chart, I will use the nations of the world data table. And we might be able to use this to understand, for example, the relationships between ecological footprint per capita and GDP per capita among different countries around the globe. So similarly, we can also use the chart and index tool and find what I have just mentioned from the drop-down menu, ecological footprint per capita on y-axis and GDP per capita on x-axis. So click on OK again. This will bring up this chart with all different countries around the globe. And similarly, we can click and drag and label them as easy as that. So this is the kind of chart that can only be created with the sustainability database. And also this is a very good chart. Also a very interesting starting point for class discussions to explore different reasons behind this distribution, or you can maybe also use this to check if there's a pattern of this distribution across continents on these two parameters. And of course, there are many other related parameters you might be interested. So this is just for you to see that it's a possibility. There's a possibility of us to create this kind of chart, use the data we have within Grant EduPack. So I think due to the time limit today, I will probably stop here. And if you're interested in knowing more of, like, for example, the equal audits, the synthesizer tool, and also how you can use the software in other ways to enhance your materials teaching, please feel free to let us know, and we'll definitely have a separate discussion with you on this. So for now, let's move back to our slides and continue with some other features and resources within Grant EduPack. So the other feature that might be worth mentioning is the material data for simulation. And this is added in 2021 to all level 3 databases. And the material data for simulation at level 3 containing over 700 materials to help with simulations. It includes the following nonlinear and temperature dependent properties handy for simulation use. In addition to that, the other important half of Grant EduPack is what we call the teaching and learning resources here. Here are more than 350 teaching resources covering various levels of material education. Let's move on to see what we have here. So we have stored all the teaching resources on the Grant Education Hub. And if you go there, it has everything that you need to have to teach materials. We have various sections denote various activities. The teaching resources section has, for example, lecture slides, case studies, projects, exercises, papers, and more. So for the resources listed here, though we are trying our best to make the materials open access as many as possible, in order to protect some of the advanced data, there are materials that still need an account to access, which is what we call my Grant account. It usually comes together with an active Grant EduPack license. However, our team will be very happy to set up a temporary one for you if you would like to explore a little bit here. And here are some examples of the available teaching resources. We have developed presentations for lecture slides. We have real industrial case studies for inspirational learning, with white papers on different case studies and database functionalities. We have some exercises as homework or exam references. We also have video tutorials to showcase general software usage. You have seen the links in the software I just showed you. And also we have prepared project files for our case studies. And in addition to that, we also have some teach yourself booklets by Professor Mac Ashby himself. In these booklets, it's not only about like difficult concepts in materials related courses. It's also a booklet, for example, on how to write a journal paper. So it's basically helping students for them to get through their undergraduate study. So here are all different kinds of resources that is ready there to fit different teaching needs. And usually, how are these teaching resources used? So there are different levels. For the introductory level, to support material science teaching, there are different teaching packages. And I have listed here one of them on the phase diagrams. So this package provides a set of resources around introducing phase diagrams in the classrooms. These resources were designed to be very useful to even used separately. So currently we can see that the package contains, first of all, the lecture units, the students' note sheets, exercise bank, quiz question bank, and also some macro projects and concept map prompts. And for the exercises, quiz questions, macro projects, and concept maps, all of these contain a student-friendly version as well, because they might need to take notes there, or they might want to use it slightly different when we are really teaching with them. And in addition to that, of course, for the exercises, there's also a solution menu. And these resources are well integrated with the material science and engineering database within Grant EduPack. And also within the package, there are a lot of figures and definitions we used like the same. It's either coming from the software or the term is the same from the software. So therefore, our hope for this package is that you can easily use this combining together with EduPack, so that when you teach phase diagrams to students, you can find a range of different resources. And then for the more traditional material selection in mechanical engineering courses, the other popular way of using our teaching resources is to use the real industrial case studies in project-based teaching. This fits teaching needs at different levels. Even though some of them are quite advanced, but we've talked with academics saying that they are using this for introductory level students because they find it sometimes it's interesting to challenge and trigger interest using this slightly challenging materials. Also, these are very handy materials to use if you need ideas on the project work. Basically, they are also great examples to teach students about Professor Ashby's material selection methodology together with his textbooks, if you're using any of them. Well, for intermediate and advanced projects, project-based teaching, other supports that Grant EduPack can provide are, it can be used as a comprehensive, consistent, reliable resources with additional specialized data. We have here, for example, fatigue strength against numbers of cycles. And it also simplified material selection with all the selection tools. Here is a screenshot of the performance index finder when you need to consider the geometry and loading conditions during the design process. In addition, with the exporters, it will be feasible to continue optimizing the design with some simulation packages later. So we also have the Learn Online website with more up-to-date materials. For example, the Getting Started menu and all the relevant material for students to use if they would like to explore EduPack. At the same time, materials for lecturers to prepare their lecture slides as well. Generally speaking, Learn Online is focusing on providing additional supports to users related to different aspects of material science and material selection. For example, one area of interest is material selection, which has additional information regarding performance indices, just mentioned briefly in the previous slides. And to keep on further supporting and bringing teaching inspirations, we also provide virtual seminars or webinars, and also a new case study based on training every quarter. And we have these webinars on advanced level industrial case studies, or we use these webinars to introduce new functions and features. This table briefly summarizes what we have planned for the first half of the year, covering a wide range of topics from battery design to material data for simulation in bioengineering, from teaching material science to teaching sustainability. Please feel free to join us and also discuss with us in real time. And in addition, we have a growing material educators community who meet at different times in Cambridge, North America, and sometimes in Asia during our materials education symposia. Here is a nice group picture of the International Materials Education Symposium held in the University of Cambridge in 2019. So compare with the most conferences or symposia focusing on research, the Material Education Symposium is unique due to its emphasis on teaching materials and how to help undergraduate students learn about materials. For the international one, we invite educators from the globe to get together in Cambridge to share and discuss the new approaches they adopt, new tools they start to use, or even the new curriculum they have developed in materials education. At the same time, to adapt to the current situation, after our first online material education symposium last year, we are thinking to extend our invitation to all educators in engineering education to enhance our current material community with more educators in engineering education with similar formats as the material education symposium, but covering more topics such as simulation. We are looking forward to meeting you online if you're interested for the Global Online Engineering and Education event soon. So a very quick summary before I hand over back to Sarah. With all the databases and tools, Grant EduPack can be used in many different ways across all years of study and throughout different departments to support and help enhance introductory and advanced materials processes teaching. In this image, you can see the different areas where Grant EduPack is mainly used. Approximately 70 universities we work with use it across multiple departments and use it as a campus-wide resource. So I guess that's all from me for today. Thank you very much for your kind attention. Now I would like to hand over back to Sarah. Thank you.
Thank you very much. The acquisition of Granta by ANSYS. ANSYS has keep on developing Granta with the Granta team, making sure that all this information is still available for you. As when showed, Granta EduBack is such an add-on to your teaching, not only for students, not only for graduates, but also for research projects and even PhD students. You can see that Granta EduBack is such a user-friendly and intuitive tool to really contribute to that material selection, material knowledge, and using those properties on different levels. We also have, again, the commercial side of the Granta products. Should you have any interest in that, don't hesitate to contact us about that. But mainly we want to focus on Granta EduBack because it is important to teach everyone about materials. Going further, just to give you the final information on how to reach out to us, please, if you have some other questions, you can either send us them now in the comment box. If you just come up with a question later, don't hesitate to contact us. We have Adrian of our team that is responsible for the Belgium universities or schools and the Luxembourg schools, and myself for the Netherlands. So should you have any questions about licensing or any other tools, don't hesitate to let us know. I think we can go then further to our Q&A because I see that there are already some questions.
Do you take them, Sarah, or shall I present?
You can ask the questions. I can't see them.
Okay, the first one I have is from Diego Ribas. It is for Wen or maybe Sarah. The mentioned events, are they exclusive for the license owners or are they also possible to join if you are not a license owner? The events which you mentioned.
Sarah, can I take this one?
Of course.
Yeah, so yes, actually, those events are welcoming all the educators with or without a license, because we are not really, trying to promote the product during the events. We are trying to basically supporting a community to create a space, to create an event for everybody to get together and share the experiences. So everybody are welcome. As long as they are teaching materials, and for this year's online event, as long as you are teaching engineering related subjects, you are all very welcome to join us for these sessions.
Okay,
I hope this answers your question.
Yes, sure. Is material database covering also cryogenic range of temperature, depends property, let's say down to 70 K?
As far as I know, we have temperature dependent data, but it's mostly for high temperature applications. So for that, we might need to further develop on that. But thank you very much for your suggestion.
Okay, thanks. I have another one. What are the best practices when selecting materials?
Oh, so this is actually a very interesting question. So as I mentioned, I have like Sarah also include that in her introduction, that we are actually the spin-off from the University of Cambridge, and we started as a teaching project in the engineering department. So basically at that time, Professor McAshby is trying to include the computer technology into classrooms for, like, I think it's early 1990 time, so it's kind of a new technology then. They are trying to help students to understand how to use these handy tools to make material selections faster. So that is why besides the tool they have developed, they have also developed a methodology that's working together with the tool. So we currently call it systematic material selection methodology, but basically what we do is to translate the design requirements into 3 different levels: function, constraints, and like objectives. So basically for the function session, we will summarize like what are the basic functions this material selection project need to fulfill, and then we apply some constraints. For example, which temperature this should work. Like, is it would this product work, for example, with water around it, that kind, like on the durability end. And then for the objectives, we define if we want to optimize or minimize a certain kind of property. Usually for the product design, it's on like we want less mass, for example, or like lower cost. So that's how we usually break down all the design requirements for the project, and then working together with the tools we provided with EduPack, you will working together to screening down the candidates of materials, and then you will end up with the best one candidate or a couple of candidates. Yeah, I hope that answers your question.
Thank you very much, Wen. Maybe a final question, because I also had a question about, can we add our own materials? If there are some students who are experimenting with materials that don't seem to be in the Kanta EduPack database. Is it possible to add that materials?
Yeah, it's actually possible. And I'm thinking, can I still share my screen?
Let me give you the presenter.
Yeah.
All right.
Is it working? No?
Yes.
So you can see the screen of EduPack, right?
Yes.
Yes.
Perfect. So it's also a very interesting question, I think. Yes, because even though we are saying that we are comprehensive databases, we are trying to include all the engineering materials on the market. But since students are learning and since the research is going on, there will definitely be times that we can't really find the materials I want to use, or I want to compare with the existing materials in the market. So for students to do it is quite simple. They can go to the tools in the main toolbar, and they will directly see the adding records function here. So what they can do is that they can actually choose what kind of templates they are going to use. So for example, we have used the materials universe, and I will keep that one. And then if we choose that one, you can see it will return with a list of all the properties that I've mentioned when I introduced the structure of the data sheets. And then the students can use the data they have at hand to populate all the different properties here. And after they populate all the necessary properties, they can click on OK and create their own charts, and then they can use this data to compare with all the existing materials within the database.
Okay, thank you very much, Wen. I think regarding to the time, I don't see any other questions for now. So I want to thank everybody for today, for attending today's webinar. If you have any other questions, please reach out to Sarah, Wen, and in Luxembourg and the French-speaking people to Adrian or David. On behalf of the team of Infinite, Sarah, ANSYS Kanta team, Wen, and I, we thank you for joining us today. Have already a nice afternoon and wishing you a nice day, and especially of all, stay safe. Thank you very much. Bye-bye.
Thank you.
Thanks, everybody.
Thank you. Have a nice day. Bye.